Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. This is Equation of a Circle Part 2. We derive the formula of a circle given its center and radius, and we do the following problem. In Part 1, we learned how to write the equation of a circle that had its center at the origin 0, 0, and that would be x squared plus y squared equals r squared, where r is the radius. So now in this video, we're going to work on writing an equation of a circle if it's not necessarily at the center. The center is not necessarily at the origin. So what's the equation of a circle for any center? Right, given its radius. So remember the definition of a circle, it's all the points equal distance from some center. So I'm going to be general here. Let's say we've got some center. Let's say the center has some ordered pair, and I'm going to call it HK. All right, so I don't know what that is. Maybe it's at the point 3, 2. Maybe it is at the origin 0, 0. But we're going to be real general here. So we have this ordered pair. I'm going to call that C for center, and that is HK. So that's some ordered pair, right? Somewhere in the XY plane. I don't care where the x-axis is and the y-axis is. This H could be any number, positive or negative, etc. Same for K. And then we have a radius, right? And that goes to how far it is, the distance to some point on the circle. So I'm going to say my circle, like this red point, is a point on the circle, all right? It's r units away from HK. So this is something on my circle. Remember, a circle has infinitely many ordered pairs, so this is a general ordered pair XY. For instance, I could have gone the radius, it looks like it's about that far away. I could have put it here. If I drew enough of these, I'd be able to draw a circle, right? So I'm not that great at drawing circles, but you get the idea. So the distance to any point here, it doesn't matter where it is, it's r units away to any point. So what we're going to do is we know that the distance from HK to any point, which I'll call xy, is r units. So I'm simply going to use the distance formula again, like we did in part 1. So what's the distance formula? All right, you have the big square root sign, remember? And then you do parentheses, a minus sign squared, and another parentheses, minus sign squared. And that will give you the distance between any 2 points. So if I'm going to go between HK and XY, we know the distance is r, right? That's the whole definition of a circle. So I'm going to do the difference between the x coordinates. So I could take my x minus my h, right? Those are the two x coordinates here. I have an x and I have an h. So I'm just taking the difference of the x and the h. So I'm going to write that in here. The difference of the x coordinates will be the x minus the h. Okay. Now the difference of the y coordinates, I could do a y minus k. Right. So we know that the square root of x minus h squared plus y minus k squared is equal to that radius. It's exactly that distance that we want. So can we simplify this a little bit? Let's go ahead and square both sides. So we get rid of that big square root sign. And we're going to get exactly what we want. Whatever's underneath that square root on the left. And this right here is the equation of a circle if the center is HK. All right, so here when the center is HK, and then we say the radius is r, we get this formula right here. So the equation of a circle with the center HK and the radius r is given by this equation. x minus h squared plus y minus k squared equals r squared. All right, now in the first video we talked about a center of 0, 0, and let's say we had a radius of 3. How would we write that equation? Remember, it was simpler. We just said, oh, it was just x squared plus y squared equals 3 squared, or 9, right? Well, we could plug that into this formula as well. This is your h, and that's your k, and that's your r. It's 3. So if you plug that formula in, you get the same thing. X minus 0 squared plus y minus 0 squared equals 3 squared. Notice how I'm plugging in 0 for my h, and I'm plugging in 0 for my k, and I'm plugging in 3 for my r. But of course, x minus 0 is simply x, so I could write this as x squared plus y squared equals 3 squared, or x squared plus y squared equals 9. Another thing I really didn't do in the first video, which I want to do now, is remember every point on that circle should work in this equation. So let's remember how we draw this. X squared plus y squared plus 9. If we recognize it's a circle and the center here is 0, 0, remember that we just go 3 spaces to the right, left, up and down from the center, which is 0, 0, and we could easily graph the circle. True? Okay. But what I didn't say, that's just the easiest way to do this. If you didn't know that, you would be having to plug in a bunch of things for x or y and trying to figure out what the other one is. So for instance, you could plug in instead a number for, you could make a table of ordered pairs. So the question is, what happens when x is 1? What would y be? Okay, that's the big question. Well, if you put in 1 for x, you would have 1 squared plus y squared equals 9. Okay, 1 squared is 1, so I'm going to subtract 1 from both sides. Y squared is 8. And then you could just take the square root of both sides. Remember that? If you take the square root, you have to put plus or minus the square root of 8. Now, if you get a calculator out, square root of 8 is, see, it's approximately 2.8. So you know what? We got 2 different values for y when x was 1. So we would get 2 ordered pairs out of here. 1, 2.8. Now that's not exact, it's approximately, and 1 negative 2.8. So you could have gone over here and said, okay, I'm going to go up and go about 2.8, and actually that is a point, and over 1 and down. And this is how you could do it. But that's a hard way to figure out that this is a circle, because you might not ever get enough points to get the idea. Now, a calculator is going to do tons and tons of points, and so you're looking if you do a graphing calculator. So if you did enough things like next you could plug in 2, you could plug in 0 for x. 0 for x is easy to plug in, right? If you plug in 0 for x, you get y squared is 9. So when x is 0, y is 3, or negative 3. So you can always resort to plugging in a bunch of ordered pairs. It's just much easier to recognize it's a circle, find the center, and go the radius up, down, left, and right, and just draw your circle. Okay, so now let's go ahead and do a problem where it's not centered at the origin. So here's a problem. First of all, recall, here's the equation when you have the center hk. It's x minus h squared plus y minus k squared equals r squared. So it says write the equation of a circle with center 2, negative 3, and radius 1. So I'm just going to write down what is h in this case. I like the way my h looks. What's h? H is 2. K. What's k? K is negative 3. And what's r? R is 1. We simply plug that in to this equation up here. So we will have x minus h. What's h? 2 squared plus y minus k. Now k in this case is a negative 3, so that's y minus a negative 3, right, squared equals 1 squared. So this isn't quite pretty. Let's just rewrite that as x minus 2 squared plus y plus 3 squared, because y minus negative 3 is the same as y plus 3. And then 1 squared is 1. So now we've written the equation of this circle. And this is the form where you could easily tell what the center and the radius is. So it's a nice way of writing the center of a circle. But you could also multiply this out, and we're going to do that as well in a minute after we go ahead and sketch it. But do you notice this? If the y value is negative 3, notice it changes and we have a plus 3 in the parentheses. Just like here, see how the h is 2, it's positive, you have x minus. So if you see a 2 here, remember you're doing x minus the 2. Got it? So be careful here. So let's sketch it. So to sketch it, when it's in this form, not too bad. Actually, I think I'm going to need a little more room here. Okay. All right, so we have a center of 2, negative 3. So I'm going to go ahead and think, where's that center? Right here, right? 2, negative 3. And it has a radius of 1. So I go from here, 1 to the right, 1 up, 1 to the left, 1 down, and I draw a circle. Remember, the center is not part of the circle. And so there is the picture of this circle. Now, of course, like I said, you could instead put in numbers for x and solve for y. Very tedious, takes a long time, hard to ever see it's a circle, so it's important to recognize this equation. Okay, so right now we're actually writing the equation. And the last thing I said I was going to do is, what's another way you might see this equation? And when it's written in this next form, you'll see it's not so obvious it's going to be a circle. I take this, x minus 2 squared plus y plus 3 squared equals 1, and I multiply it out and add like terms, etc. So see if you could do that. Put the video on pause and try that, and then I'll show you the steps. So if this was multiplied out, remember this means x minus 2 times x minus 2 plus y plus 3 times y plus 3. So I would have x squared minus 2x plus 4 using the FOIL method or any method you use for multiplying binomials. And I have y squared plus 3y plus 9 equals 1. And so we've got, if I combine all my like terms, notice I have x squared minus 4x. Now check this out. I have a 4, but I also have a 9. I'm going to hold off on adding those two, which I'll do in a minute. But I've got y squared plus 6y, and here the 4 plus 9 is 13, equals 1. Another way you'll see this is you put the x squared and y squared first, then you put the x term and the y term, and then if I subtract 1 from both sides, I have plus 12 equals 0. This is also, that's the same equation in a different form. But notice it's hard to tell what the radius is. It's hard to tell what the radius is, and it's also hard to tell what the center is. So we will be practicing. What if somebody told you this was a circle and they said graph it? Well, you'd want to put it in this form. You'd have to go backwards actually, completing the square, etc. So for now, we're going to usually keep it in this form where it's red. That's the preferred form of a circle. Okay? But this is the same circle written in a, it's like it's hiding what the center and the radius is. So we're going to do a lot more problems because I was only able to do this one little example on this video. So you want to go on to part 3 and we'll work more with equations of circle, looking at a circle and being able to write the equation, etc.